Alright, so let's go ahead and demonstrate our problem. We have a level, and it's a nice level. There's some platforms here, but then the level continues on outside of the camera's view. You can see the camera's view by this little white line everywhere. So if we go outside the level, we can't see anything. This is a problem because our player might fall into the void or, miss the target. And so we need a way for the camera to be able to follow the player. Now we can go ahead and go about this a couple different ways. First way we can do is go ahead and set the camera's position to equal the players and go ahead and reset its position. So to be 0, 0, it's already that, and then press play. Now this works, but then we have all this, nasty blue stuff, which is the default background of 2D games on Unity that we don't want to deal with. And we don't want to make our background extremely large. That might cause latency issues. It might cause your game to be a bit laggy. So we don't want that to happen. So let's go ahead and take our camera outside of the player. And let's go ahead and add a script. So I'm going to add a camera follow script. I've already made the script. It's just empty script. But you guys are probably going to have to click new script. Name your script whatever you want. And then click create and add. But I'm just going to go ahead and attach this script I've already made. So we're going to open up a Visual Studio. Let's go ahead and get rid of these. We do not need the void start and void update right now. So let's think of what we need to do. We need to set the camera's position to equal the player's position. Not too hard. So let's go ahead and do public transform, and camera. Let's do another public transform and call it player. So what we need to do is, like I said before, we need to set the camera's position to equal the player's position. So we're going to do void update, call it which is called every frame, and we're going to say underscore camera dot position is equal to underscore player dot position. All right, and let's go ahead, save this, and wait for it to compile. And once it compiles, we have to set the camera to equal camera right here, and then player to equal player. Easy peasy. Let's go ahead, press play, and see what happens. Well, now we have a problem. The camera is just showing black. Now, at first this might seem very, very confusing, but it's actually very simple what's going on. If we remember, Unity is a 3D game engine. It's not a 2D basic game engine. So it deals with 3 dimensions. We have height, width, and depth. By default, you have this 2D little box checked. If we click out of it, we can see exactly what's going on. I have my background here to be a little bit farther away on the Z, as you can see it's like 1.34, than the rest of the scene, which is the default set to 0. And so the camera is looking at the background because the camera's position is the same as the player's position. You can kind of see, as I move the 3D camera around, it's set to the exact position of the player, so we can't see the player at all. And actually, the camera is just looking at this black background that I made. And what we need to do is we need to somehow offset the camera's position so that it could still see the player. So that way we could still see the player, when we play the game. So let's go ahead and stop this code from running. And let's go back into our code and we can go ahead and delete this line. We don't need anymore. So again, we need to set the camera's position to something. And since again that Unity is a 3D game engine, we are going to do new vector3. And vector3 takes in a float it takes in a float x for the x coordinate, a float y for the y coordinate, and a float z for the z coordinate. So let's go ahead and set float x to player dot position dot x, and then for the float y, again underscore player dot position, dot position dot y. All right, and now we have to set the offset to equal. We have to set the z to equal something. Now we can either hardcore this in, so let's say a -1, f is a good number for an offset, or we can have it a public float offset. And I'm gonna go ahead and default set this to 1, -1, because -1 is a good number. If you keep everything in front of -1 on a 2D game, you'll be fine. I understand why you would not want to have stuff if you want to have the stuff in front of -1. But for right now, -1 is a good number to keep. So we're gonna go ahead and set this equal to offset. And this works. And go ahead, save. We could go back into Unity. We wait for this one to compile. We have offset right here. We can edit offset, and we actually are going to want this not to be a float. We actually want this to be an integer, so that way we can't put words in this. So let's go ahead, say integer offset, and we go ahead and delete this f here, and it still works fine in the vector3. Go back to Unity, and now we can still edit this number, but we can't put like letters in here. I'm pressing the S and D keys, the spacebar keys. We can only put numbers in here. So let's go ahead and play the game. And I'm going to take this out 2D mode. As we could see, the player can now be seen by the camera, but then we still have that nasty thing of the blue stuff, we don't want, all this nasty default background that we don't like, because, we spent a long time working hard on this background. It might be, whatever. I just have it black here, but, we spent a long, our precious sweat and tears just to see the Unity default background, which isn't that pretty. So what we have to do is we have to clamp the camera's position. And clamping might seem super difficult. Actually, it's not as difficult as you think. Visual Studio has a function called math.clamp. And this function, it takes in a float value. So we set the value that we want to adjust, and then we set a minimum of the value. So if it's like below, let's say 0, we want to set float value to equal 0, and we have a max. So let's say if it's above 1, we don't want it to go outside of 1, so we say float value is going to equal 1. Very, very simple. So all we're going to have to do is say, let's make two floats. Let's call this one X clamp, and set it equal to math.clamp. We could go ahead and leave this blank for right now, and it's going to give you an error, but that'll be fixed in a minute. Then we're going to say float Y clamp. It's going to equal, again, math.clamp. And now we can go ahead and plug, instead of position X, we can say X clamp. And instead of position Y, we can say Y clamp. And then we also have our offset. So let's go ahead and see what we need to do for clamp. Now we've said already that it takes a minimum value and a maximum value. So what we're going to do first is we first need to set what value we need to adjust. So we need to adjust player dot position. Easy peasy. So now we need a minimum value. Well, we can either hardcore this in by going to Unity getting our camera and then taking these coordinates up here, so position X. Let's say we want our position X to not go above 4, like 4. Let's say 0.4. That works. So that's the maximum value on the Y. Let's say that's the maximum value on the Y, and let's say the minimum value on the X is 0.9. Keep these numbers as small as you have to. 0.9. We don't want it to go above that. So we can go ahead and say minimum is negative 0.9, F, and then maximum is, whatever. But if you're going to be using the same script, in multiple levels, you'll come into the problem that all of the levels aren't the same size, and so you need the clamps to be different numbers, and if they're hard-coded in there, you don't want to be duplicating scripts to do the same thing just to, hardcore the number in. So what we're going to go ahead and do is we need to create 2 arrays. So let's say public, because we need them to be editable in the inspector. Let's say float array xclamp. Let's call this yeah, let's call it xclamp. And then another public float. And another public array yclamp. And then all we have to do is remember that our first number is going to be our minimum value. So in float in arrays, all arrays start at position 0. So we say for our minimum value xclamp, and then I was trying to do that. All right, let's go ahead and rename this to xclamp. Let's do underscore xclamp, just to differentiate it from the float xclamp that we have right here. So let's go ahead and say underscore xclamp. And since all arrays start at 0, we need to say take it from array position 0, and then we do float max xclamp again, and then position 1, and that will be position 2 by player.position dot we dot x, since we're doing this on the xclamp. And then we do the same thing, player, since this is going to be the y value, we say player dot position dot y, so that way it's only editing one number. Instead, if we do player dot position, it'll give us an error because you can't edit 2 numbers. So dot x here and dot y here, and then we do the same thing. We say underscore yclamp, value 0, and then underscore yclamp again 1. Very, very easy. This line of code might look a bit scary at first, but it honestly isn't. So what we're doing is we're taking the xclamp, for example, we're saying the float xclamp is going to equal math.clamp, and player.position.x, where that's the value when we want to adjust, and then we want to set it in the range of the number xclamp and of array position 0 and array position 1 of xclamp. Same thing with y, just yclamp and position.y. Then we go ahead plug in xclamp and yclamp into our vector 3 that we set the camera position to equal. Now we're going to go ahead and save this, go back into Unity, and once it compiles, we'll see that we have xclamp and yclamp. What you're going to do is you're going to set your size to equal 2. So you have, this will be element 0, which you can adjust with the slider here, and element 1. Let's go ahead and set this back to 0. And you can see here we have 0 and 1. So we need to set 0 to equal our minimum value. So on the X, we don't want our camera going past, say, negative 0.8. And then we don't want it going as far as, say, 6.9. Nice. So 6.9. Then we're going to say Y clamp. We don't want it going above. We don't want it going below first position on negative 1.5. And then we don't want it going above 0.4. Go ahead and play. And as we see, it does not go below. We can actually, if we zoom out a bit, we can see by looking at this white line as we fall, it doesn't go below. In fact, it uncenters from the player, and it doesn't go above our set coordinates. And that's about it. So thanks for watching. Make sure to subscribe. I'll be hopefully posting more videos like this. And if you learned something, leave a comment below. And if you have any bugs or any problems, also leave a comment. I'll do my best to help you fix them. All right, you guys have a nice rest of your day. Goodbye.